Hi everybody, this is our video on the area between curves. So you already know how to find the area underneath a curve. In this video we're going to talk about what to do if you want to find the area that lies in between two different curves. So let's say, for example, I had a function, let's call it f of x, and I have another function, well, let's call it g of x, and g of x is going to, maybe it doesn't matter if it dips below the axis or not. So, okay, so I have my x-axis, I have my y-axis, and I have these two functions, f of x and g of x. And let's say that I want to know how much area lies in between f of x and g of x between x equals a and x equals b. So I'm looking for this area. That's what I want to know the area of. So one thing that I can do is start sampling each of these functions at various intervals. So I could sample, say, here and here and here and here and here and here. And then, let's see, at this point, I get this value. And if I go down to g of x, I get this value. Now, if I make a nice rectangle, say we'll go, oh, how about from x equals a to whatever this point is, make a nice rectangle, I end up getting a rectangle which closely approximates the area between these two curves. So this is the same idea as when we first tried to find the area underneath a curve, only now instead of going between the function and the x-axis, it's going between the function and some other curve. Okay, so essentially I should get something pretty much the same in terms of the answer. The only difference is going to be, how do I work out the height of this rectangle, right? And the answer is, well, since f of x is larger than g of x, when I try to find the height of this rectangle, I need to take f of x minus g of x, right? So whatever the value of f is at this, or f at this point, and the value of g at this point, I just need to know what those values are. I subtract them. And so the area, I'll put it up here, the area between f of x and g of x lying between x equals a and x equals b is, well, I break this up into a bunch of rectangles, and then I want to add them up. And then I want to make it so that those rectangles get smaller and smaller and smaller, right? Real slim. And when I add those all up, that's going to be an integral. X will go from a to b. And then, as we said, I'm going to need the height of the rectangle, which was f of x minus g of x, times the width. And of course, in the limit, as those rectangles get really, really small, we call that width dx. Okay, so that's going to be our area formula for finding the area between two curves. You integrate from the left endpoint to the right endpoint, and you look at their difference. Okay, fine. There's a little bit of a wrinkle here that we want to throw in. There was an assumption. I didn't mention it when I was doing this. I kind of hid it in there, but I didn't write it down explicitly. The assumption is that this function f of x is always greater than the function g of x. That's why we wrote it in this order, f of x minus g of x, because that gave us the height. What if they switch sides? Okay, let's draw another picture. So let's say I draw my function f of x, and I go to draw my function g of x, and g of x starts beneath f of x, but it crosses over. How am I going to compute this now? The answer is, well, you basically just break this up into two separate problems. So I figure out where they intersect. So this point right here. So let's say that's x equals a, and maybe this is x equals b. And they're going to intersect at, well, how about C? And so the areas I'm looking for are really these two separate pieces. And so I'm just going to break this up into two separate integrals. In this region, it's the f of x which is on top. And so the area would equal the integral from a to c. And since f is the bigger function, the height of an arbitrary rectangle will look like f of x minus g of x. And then I multiply by dx. But when I move on to this region, now the g of x is on top. And so when I write down the area, okay, I'll start at c and I'll end at b. But now I need to do g of x minus f of x, since that'll give me the height of a rectangle. And of course we have our dx. Okay, so not so bad. So let me wipe this board off and we'll do an example. Okay, welcome back. So I put up here a graph of the function x squared minus 1. So you see it starts down below the x-axis, comes on up, hits the x-axis, and goes off forever, but we're going to stop it when x is equal to 2. And I'd like to know the area not underneath the curve, because if I computed it in the traditional way, this would count sort of as negative area. I actually want to know what is this area as a positive number, right? I want the absolute value. And what is this area, and I want them put together. Okay, so in this case, my function here is f of x, and what's my g of x? Well, it's again actually the x-axis, right? It's just the line y equals 0. So that's going to make things a little bit nicer, but conceptually no different. So if I want to compute the area, I need to break this up into two pieces. Of course, I need to know where that point is. So where is this point going to occur? Well, this occurs when x squared minus 1 is equal to 0. And this happens when x is equal to plus or minus 1. But of course, the minus 1's on the other side. I'm not interested in that. So this must be x equals 1. So when I compute the area, I'm going to break this up into these two different regions. In the first region, the line y equals 0. So remember, the x-axis could also be written as y equals 0. Y equals 0 is the larger function. F of x, x squared minus 1, is the smaller function. And then in the second region, it's x squared minus 1 that becomes the larger function, and y equals 0 is now the smaller function. So the area is going to be the sum of two different integrals. In the first region, we go from 0 to 1. And we need to put the larger function, which is just 0, first. And we subtract the smaller function. That's our f of x, or x squared minus 1. So there's our f of x. And of course, we multiply by dx. Now, why did I put these parentheses here? All right, this is somewhere a lot of students are going to make a lot of mistakes. If you don't put the parentheses, then this would read 0 minus x squared, and then minus 1. And so you'd put the minus on the x squared, but you wouldn't put the minus on the minus 1. And that's going to give you a different answer. Remember, we're subtracting the function, and the function is this. So you have to put parentheses around it so that this becomes negative x squared plus 1. If you don't do that, you will get the wrong answer, period. Okay, so put your parentheses. When in doubt, put some parentheses down. Now that just gives us the first one. So what about the second one? So the second one, well, now we're going to integrate from 1 to 2. So we get here x equals 1 to 2. And now the larger function is our f of x. So that's x squared minus 1. I don't actually need the parentheses here, but maybe I just put them there just so it's very clear that that's my function f of x. And then I need to subtract the smaller function, which is 0. And then everything times dx. Okay, so I'm not going to work through all these computations. I'll tell you, if you do all this, you'll end up with 2/3. All right, that's a good little exercise to go through. Nothing complicated here whatsoever. These are very, very basic antiderivatives. Okay, so this is not a complicated issue here, but it's very easy to go wrong if, one, you don't decide which is the larger function, two, you don't realize it may switch over at some point. So if you have an f of x and a g of x, make sure either you plot them to see or at least set them equal to each other to see if there is a point in your domain where you're going to have a switch over as to which is larger and which is smaller. Okay, once you do that, you should be okay. But here's a little tip. If you get to the end and you'd work this out and say you'd gotten negative 2/3 or something with a negative sign, is area going to be negative? No, no, no. Which means you probably got things in the wrong order. Now, I'm not telling you just write it down in some order. If you get a negative, then switch it. Okay? Try to get it though the correct way first. Put that f of x on top, put that g of x on the bottom, or vice versa, depending on which one is bigger or smaller.